clear to all of you. Okay, and then we can start with those questions of mirror formula again. Okay, so here, as for the, we define with the sign conventions only. We'll start with the sign conventions. But before that, let's understand the term magnification. This is an important term which tells us how the image will be formed. It tells us a number of things about the image formation. So in the chapter light, we are starting with magnification. Magnification, it is the simple ratio, or it is the ratio of height of image to the height of object. Ratio of height of image to the height of object. The ratio of the height of image to the height of object is called as magnification. Now see, its formula, as from the definition we can say that magnification will be given by m equals height of image over height of object, hi over ho, which will give us the magnification. Now considering a little bit of sign conventions, if we observe here, so all the measurements, let this be our principal axis. So with regard to the principal axis, we discuss what all values this magnification can have. So on the principal axis, all the measurements which are made above the principal axis. So the measurements above the principal axis will be positive measurements, and all the measurements which are below the principal axis, the measurements which are below the principal axis, they are negative measurements. So this measurement here, let's say, let this measurement be EB. If I mark this measurement as EB and let this one be PQ, so here AB will be positive and PQ will be negative. Everyone understood this?
Yes, sir.
Yes,
Okay.
sir.
Now from this formula of magnification, say you have the formula of magnification given by height of image by height of object. So if you get the value of magnification as some positive value, if I get magnification as positive, so what does it mean? Suppose I obtain the value of magnification as +1. So what can you say about the image? How is the image formed? Is it inverted or is it erect?
Direct.
Yes. Yeah, it will mean that the image is erect. Image is not inverted, it's erect here. So image is erect since the value of magnification is positive. So we find here the image is erect. Okay. If you get magnification as negative, let's say I get magnification as -1. So negative value of the magnification will be obtained only when the height of image is negative. Since height of object will always be positive. If we find out HO, height of object, it will always be positive. Since object will always be placed above the principal axis. So we will observe height of object always positive, but height of image, if height of image is positive, then we will get a positive magnification. And if height of image is negative, so then we will get a negative magnification. Right? So what all information can you get from this? If suppose you have magnification as +1, so what information does it convey to you?
That the
Object is of same size
same size
and
and
virtual. Correct.
Yeah, image is same size and virtual, right? So which mirror can form such an image?
Plane.
Yeah, plane mirror. So if you spot magnification as +1, so we know that we are using a plane mirror, and in the plane mirror we have virtual erect image formed. What about this magnification as -1? What if we get magnification as -1 then?
Image is real.
Image is
inverted.
real inverted. Okay. Image is real inverted and same size. Real inverted and same size. Okay, and can you tell me that which mirror will give me this result? Real, inverted, and same size.
Concave.
Concave mirror. And where should I place the object so that I will get this result? Where should the
C.
at
At C.
at C? Very good. So this way we are able to guess. The next one is about the sign conventions of object distance and image distance. Okay, so this was regarding the sign conventions of above the principal axis and below the principal axis. The second sign convention we look for Cartesian sign conventions. We call all these conventions, we call them as Cartesian sign conventions. Okay, see, if you draw a number line, so as of now, up to now, we have learned that a number on a number line, everything which is towards the right of 0 is positive. If let this point be 0, so to the right side, you will have everything which is positive. You will have +1, +2, +3, so on. And on the left side, you make the negative numbers -1, -2, and -3, right? So on. This is what we have learned up to now through the number system. Yes?
Yes, sir.
Yes.
Yeah. So through the number system, we have learned here that the magnification can be, sorry, on the towards the right side, it will be plus, and towards the left side, it will be minus. Now, can I take the left side to be the plus sign? Can I take the left side to be plus? Yeah. Should I? Is there any condition under which I can take the left side to be the plus and right side to be minus? Yes. Not in mathematics, but in physics, we can take like this. In physics, we can take the left side to be plus and right side to be the minus. How it is possible? Let us see. So first we will observe the first we will observe first we will observe that what does the Cartesian sign convention states. The statement of the sign convention, it states that, so from the sign conventions we know that all measurements are made from pole. So you have to make all the measurements from pole. This is first point. And second point states that all the measurements which are taken in the direction of incident light, the measurements which are taken in the direction of incident light, they are taken as positive. So second point, we'll understand the second point. Measurements in the direction of incident light are positive. So first we will understand this with the help of a plane mirror, and then we will apply the same thing to the concave and convex mirrors. So I think that all your cameras are off. Can I see anyone's camera on? Please keep your cameras on. Okay. Siddhisri should join. So see, I will try to understand this with the help of a plane mirror. Suppose we have a plane mirror. What does this statement mean? So we take a plane mirror and we polish it. So we polish it on one side like this. So let this be one of the plane mirrors. And so this is a plane mirror. And I take a second plane mirror over here, which is like this. So on the first plane mirror, let us have an incident light. Let this be the incident light, which is falling towards the mirror. Now, for the plane mirror, we will be making all the measurements from the mirror. All the measurements will be made from the mirror. Okay. So which direction to be taken positive for this mirror? For this plane mirror, we will be drawing the number line like this. We will draw the number line like this. We will mark our 0 at the point where this is our 0. It will be marked at the point where there is mirror. Now, the measurements in the direction of this incident light. That means from the mirror in the direction of measurement, that means behind the mirror. Okay. So if you are making any measurements behind the mirror, measurements behind the mirror will be positive, and measurements opposite to the direction, the measurements in the opposite direction, they will be negative. So we will take this measurement as negative and we will take this measurement as positive. So this will follow our number line. On the number line, we can take that this side to be the positive side and this side to be the negative side. Now, what about this mirror? If you observe this mirror, your incident light will now be falling from this direction. Now, this is the direction in which your incident ray of light is falling. Okay. So, in this ray of light or here, which direction to be taken as positive? Left side or right side? Which direction we will take positive?
The left.
Left side.
Yeah, for this, we will be taking here left side. For this mirror, we will make like this. On the left side, we will take the positive measurement, and on the right side, we will take the negative measurement. Okay. So understand this, that the direction of the incident light is taken as the positive direction, and the direction opposite to that is taken as a negative measure. The same thing we apply to the concave mirrors and convex mirrors. So let's make a concave and convex mirror and see how these things are applied over there. So, so this is a concave mirror, and okay. So for the concave mirror, I mark the center of curvature. In the middle, I mark F. Here I mark the pole. Shade the outside. So this becomes a concave mirror. Okay. Now for the concave mirror, what sign should be taken for radius of curvature? Yes. What sign should be taken for radius of curvature?
Negative.
Negative.
Negative. Since the direction of the incident light, see, now the light will be falling like this. So light will fall like this, and hence from we have to make all the measurements from pole. So if we move from pole like this direction will be the positive direction. This will follow our number line. This will be positive, and in this direction it will be a negative measure. So here we will find that radius of curvature will be negative. We also find here that focal length. Focal length will be positive or negative?
Negative.
Yes.
Negative.
Focal length will also be negative. What about the object distance?
Negative.
Negative. Here object distance will also be negative since object is also located in front of the mirror. So object distance measured from pole will be negative. And Image distance can vary. Image distance, if it is a real image, so image distance will be negative. If it is a virtual image, then image distance will be positive. Okay. So image distance can vary in the case of concave mirror. Now again, if I draw this concave mirror something like this, suppose I change the mirror, again I have the concave mirror. So this is our, sorry, I have not drawn a convex. Let me draw it as concave only. Just 1 minute. Now I draw it like this. Okay. So for this concave mirror, what should be focal length? Should the focal length be positive or negative?
Negative.
Yeah. Still the focal length will be negative. Still you will find that the measurement is opposite to the direction of light. So here still you will have focal length as negative. We will get F to be negative. We will get radius of curvature as negative. Since the direction of incident light is like this. So now you have this direction as the incident light. So all the measurements behind the mirror will be positive and measurements in front of the mirror will be negative. This is a positive measurement. Here, the measurements like this will be the negative measurement. Okay. Now for the convex mirror, the scene changes for a convex mirror. For a convex mirror, the object distance is negative and everything else is positive. Hmm? So let's say concave mirror. This is now a convex mirror, right? So for the convex mirror, we will find our focal length, which will be positive. We will have center of curvature. This will also be positive. As now the direction of incident light is like this. So this is the direction of incident light. So the measurements, now these measurements, they are in the direction of incident light. They will be positive. These measurements, they will be negative. Okay. So now can we move on to some questions?
Yes, sir.
Yes, sir.
Okay. So I'm just sending a few questions in the, and then we'll be able to do those questions. Just 1 minute. Let me share those questions in groups.
Sir, can't you show them?
Yeah.
Can't you show them now, sir? Like, or
Yeah.
can't you share them here?
Yeah. I'm sharing here also and in the group also. Both the places it will be there. Okay. Just 1 minute. It will be at both the places so that you can have an added advantage of it. Just 1 minute. Getting those assignments. Okay. So See, I think it's visible to everyone.
Yes, sir.
Okay. So these are some of the simple questions. Uh, we now move to these questions where we have here all the questions are from lenses, and I need question from mirror. Uh, just one minute. Okay, this one. Let's see question number 33. We got this question number 33 and 32. Let's do question number 32 and 33. Okay. For your first question number 32 states, find the position, nature, and size of the image of an object 3 centimeter high placed at a distance of 9 centimeter from a concave mirror of focal length 18 centimeter. So in question number 32, if you observe all the information, what all information we get from question number 32. So you have answer 32. First of all, we have this 3 centimeter. So what is this 3 centimeter?
Height of object.
Yeah. So we'll write with the symbol HO, height of object. This as plus 3 centimeter. Then the next part is placed at a distance of 9 centimeter from a concave mirror. So this 9 centimeter would be the object distance.
Yes, sir.
Yes. So we'll write this as U equals to minus 9 centimeter. Since it will be negative, object distance is always negative. Then focal length is 18 centimeter. So we write here F equals plus 18 centimeter. Plus or minus? Should the focal length be plus or minus?
Minus.
Minus. Since it is a concave mirror, and for the concave mirror, the focal length is negative.
Negative.
So we will give this focal length a negative sign. The focal length will be negative, not positive. So we'll have focal length minus 18. Now, we want to find out nature, position, and size of the image. So position means we want to find out V. So we will be using the mirror formula. So can I expect your answers within 2 minutes? So it should be 1 by F equals 1 by V plus 1 by U. This is the mirror formula. And now put the values. We need to put the values at the correct places only. So at the
Sir,
place
is
of,
it minus 18?
yes,
Is it is it minus 18?
the answers are here. The answers are here. You have B as 18 centimeter, H as 6 centimeter. So just check if you are getting the correct answer. V has to be plus 18 centimeter. Zoha, are you getting the answer? Zoha? Okay. Okay, so you're still doing fine. Shubhansh? Shubhansh, what about you? Okay. Siddhisri? Now, if we put the value, we get here 1 over minus 18 equals 1 over V plus 1 over U, which is U is minus 9. So in the next step, we take all the negative signs in the numerator. Taking all the negative sign in the numerator, you will be getting here 1 by F equals 1, sorry, we have already put the value over here. So we can write
Sir,
minus 1 by
V
18.
equals to 18, sir.
Yeah, V equals to 18 centimeter. That's what you should be getting. So what is the nature of the image?
Sir, doing, sir.
Okay.
Yeah.
See, the image distance is positive.
It's enlarged.
Yes, sir.
Enlarged and virtual mirror.
Okay. So you get here V as 18 centimeter. We obtain V equals to 18 centimeter. We have V or image distance equals 18 centimeter. Since it is a positive value, that means image is found behind the mirror. And when image is found behind the mirror,
Virtual
this
and direct.
image is virtual and erect. So we obtained here, we can say image is virtual and erect. Now,
Sir, could you once say how, sir?
how?
Yes, sir. I forgot,
Okay.
sir.
Okay, do you remember the ray diagram for concave mirror?
Yes, sir.
Okay, so take out the case when the object is placed between F and P. Okay, see ray diagram of concave mirror. This one. Okay, this last one. When the object is placed between pole and focus.
Yes, sir.
Got it? So here, if you get the image between pole and focus like this, observe this image. So here you have the formation of virtual image. The image is found behind the mirror.
Yes, sir.
Okay. So this is the reason when we get object distance or image distance as positive, it means it is located behind the mirror and therefore it will be virtual and erect. Now, how can we find out the size? Siddhisri? Siddhisri, how can we get the size of the image?
Sir, may I tell?
Yes,
So it would be enlarged.
it would be enlarged, but if you want to find out the exact size, we will use the formula of magnification as HI over HO equals minus V over U. So magnification is also given by the formula. You can add it if you do not have. Magnification is given by HI over HO and it's also given by the formula minus of V by U.
Sir, magnification equals to -2, sir.
Okay. So put the values here. HI we want to find out. HO is given to us, which is the height of image, a height of object, that is 3 centimeter. You have height minus
So
and
it
V
would be positive.
we have got is plus 18. U age minus 9. So these cancel, you get magnification as 2 Multiply this 3 to the other side, you get your answer height of image as 6 centimeter. Has everyone obtained the answer?
Yes, sir.
Yes, sir.
Now, can you obtain the answer for question number 33? Do question number 33. Okay, see. So for question number 33, we are given,
Sir, I got the answer.
okay. So what did you get the answer?
Sir, minus 40.
Minus 40, yes. So image distance should be minus 40, that is correct. Also find your magnification. Find the magnification. Mark it. So find out the magnification, also find height of image. Yeah. So find out its magnification.
So -1.
Minus 1.
-1. Yes, sir.
Okay. Minus 1. So what is the height of image?
4 centimeter.
Yes.
Sir, height of image. 1 minute, sir.
What should be the height of image? Tell me all three things. I want for this nature, position, and size. All three things.
Sir, nature it is real and inverted, no, sir.
Yeah, it is real and inverted
And of same size.
and same
Same
size as
size.
the object. Yeah, it is same size as the object. So
So
can you
it
tell
would
me where is the object placed?
at C.
At C.
Okay, can you draw the diagram for this case?
Yes, sir.
Okay, so draw the diagram for both the cases. Draw the diagram for question number 32 and 33. So this is how your new questions are asked. Okay, so see, I think you can draw the diagram for these two for these two. Question number 32 and 33. That is your homework. I'm adding here that part as your homework. So draw diagram. Anyone having any doubts?
So once can you draw
Sir.
the diagram for the previous question?
Diagram for the previous means the 33.
Yes, sir. Like of inverted image of the same size.
Okay.
Only placed at C.
you have to place the object at C. See, just one minute. I'm drawing. So you have to take something like this. You have to take your compass, and this is a very typical diagram. So for this, you have to take your compass, mark the pointer C, and make a small cut so that you know that this is your point F. Then take your compass again ahead. This is how you have to work with your in your notebook. So again, mark one over here and take this. Now from the center of curvature, extend your compass up to this point. This is your point 4. So now you can draw your mirror like this. So you will be getting your exact answers. For the exact answer, you have to use this method. At this place, you have your C. This is our C. This is our F, and this is our pole. Now you just shade your mirror like this. Keep the object at C. So you keep your object at C like this and use the rules. You will get your exact image if the the focus is exactly in between pole and center of curvature. Okay. So use the two light rays. Here I am taking one of the light ray going parallel to the principal axis. So after reflection, this light ray passes through focus. Now we take the second light ray passing through focus, and this will come out to be parallel to principal axis. So like this. Okay. You can adjust it and you will be getting your image at C only. See? You will get your image at C. So this is how the diagram looks like. Okay. If you find out any problem still, you can ask in the next class. Okay. So bye everyone. I hope you have understood this. Okay, so yeah, so draw the diagram for question 32 also.
Nice. Thank you.